People of the internet, welcome to Modern Day Debate. Tonight we are debating creation versus evolution, and we are starting right now. So I am Kaz, host of the Atheist Edge. Tonight I am joined by JF Gariepy and Sal Cordova. They're going to each be having 6 minutes each for opening statements. Then we're going to do 6 minutes of rebuttals, a 30-minute open discussion, and then a 35-minute Q&A. And I believe Sal is going first. So Sal, at your first word, I will start the clock. Do you hear me?
I have my slides, so we can go.
Okay. Ready when you are.
The great tragedy of science is the slaying of a beautiful hypothesis by an ugly fact. There are many ugly facts which will slay the theory of evolution. I'm going to just be like a Gatling gun in my opening here. Short debate formats are for theater. They're not so good for technical topics like tonight. Also, Brandolini's law inhibits discovery of truth. 200-hour-long debate formats are better. That was really well illustrated in the internet duel between James Tour and Dave Farina. James Tour just, I think, totally demolished him. James Tour also pointed out all the problems of the origin of life theories, including the RNA world and other things. Beyond that, it's being seen in peer-reviewed papers that are now by a very good biologist, Eugene Koonin, that are invoking multiple universes to solve the problem. He specifically cited problems with the RNA world. Also, here's another paper along those lines. This is a really great paper, the prebiotic chemistry and human intervention. A lot of the supposed advances in origin of life chemistry are basically human intervention, not anything that's natural. It's called the hand of God dilemma. So that was the abiogenesis phase. In the evolution phase, which could be the topic of tonight, the idea that evolution kind of grows naturally into organs of extreme perfection and complication, I think that's been demolished by Michael Behe, but really more not just by him, but by the data. Indicative of this, it portended an experiment in 1965, Spiegelman's monster, where we had an RNA that replicated, but it actually started out at 4,500 bases, and then natural selection made it replicate down to 218. They cited this as an example of natural selection at work, but it portended disasters for Darwin's theory and that Darwin devolves. Behe put his ideas, he reviewed many experiments and showed most evolution is devolution in the Biology Quarterly 2007, and worse for the theory 2017, genome decays despite sustained fitness gains in the long-term evolution experiment by Lenski. This does not portend well. And papers like genome reduction is the dominant mode of evolution, also by Koonin and Wolff. So what would be the problem? How does this resolve? We have old Earth creationism postulating miracles. Nobel laureate in chemistry Richard Smalley was an advocate of this old Earth progressive creationism, where the rise in complexity in the fossil record and over deep time happened through a series of miracles. Alternatively, although this is fringe and extreme, we have young Earth creationism, the idea of young life, the fossil record, Earth and the universe are young, like say less than 10,000 years. We have good scientists representing that case. Physicist John Gideon Hartnett and retired Cornell research professor, famous genetic engineer John Sanford up here. So what would happen with young Earth creationism? It's like the bent pencil. It's an illusion, according to Snell's laws of physics. If the fossil record is young, to prove this, physics and chemistry may show that the appearance of age is a similar illusion. Going back to evolution, here's a statement, headline in 2013, if ENCODE is right, then evolution is wrong. Evolutionary biologist Dan Grauer. This is a disaster because ENCODE is right, therefore evolution is wrong. To understand this comes from the work of Hermann Muller, Nobel Prize winner in physiology and medicine, and a paper he published in June 1950. It still holds a lot of weight. It was elaborated on mathematically by Kimura in 1966. Now, I've gone through the trouble of using the Poisson distribution and elaborating Kimura's work. If anyone wants to really be tortured on this, we can do that. I'd mentioned it in a Springer Nature reference work that is now on university shelves. You can buy it if you want for $1,500 direct or through Walmart for $819. But math aside, The basic problem is if natural selection is supposed to keep the best, toss the rest. I'll simulate that. Hasta la vista, baby, with the Terminator. He's going to get rid of the worst. And it looks good like evolution works. The problem is what happens if all the creatures, individuals, have a mutation. Mueller addressed this point, and so did Kimura indirectly. And you can't eliminate everything. Therefore, the genome is deteriorating. There have been speculated mechanisms to try to rescue this, and the data just doesn't show it. And therefore,
1
evolution
minute
is
left.
intelligence, and childlessness is an example where natural selection causes decline in IQ. And here's some more evidence for that. This leads to testable predictions. I had the privilege of working with John Sanford for 7.5 years on his theory of genetic entropy. He was an atheist turned Christian turned creationist, and he's a world famous genetic engineer. He thinks our genome's decaying. There are two alternatives. One of them is genetic engineering, where we end up with this singularitarian matrix type world. The alternative, the creationists proposed, is theological, outside of science, that Christ will return. Bottom line is, I think Dawkins' view of the blind watchmaker is going to fail. And that's pretty much all I have to say. Thank you very much.
All right.
All right. Thank you so much, Sal. I really appreciate it. And we're going to kick it over to JF for his opening statement. JF, the floor is all yours.
Okay. So Sal is taking issue with the theory of evolution, both because of the ongoing evolution, and he doesn't think that it can sustain the creation of the species diversity that we see today from common ancestry. And he takes issue also with subjects around the origins of life, around the RNA world, and around, I don't know, maybe my theory, because it seems that he has read my book, The Revolutionary Phenotype. I'd like to hear him talk about this. He says the RNA world has problems. It is not because a scientific theory does not reveal every detail of what happened that it is incorrect. To show a current scientific theory is incorrect, you have to show that something truly doesn't work, that something is impossible stemming from that theory. The RNA world theory, as it stands, is a very realistic interpretation of what led to DNA. That is, before DNA was there must have been a life form that was RNA-based, and I consider that I proved the RNA-based theory with my book, with my theory, the theory of phenotypic revolution. To make a long story short, when you consider what would be needed for a replicator to create another replicator, you reconstruct what happened 4 billion years ago, you reconstruct the circumstances during which DNA has emerged, and DNA cannot have been the first replicator for arguments that I list in my book. It's simply too complex. The system of changing from DNA to RNA and then from RNA to protein, this cannot show up instantly. Therefore, we must have a theory of transitionary of transitions between protein to RNA and between RNA to DNA. There is no problem with that theory. In fact, it is extremely well supported. The theory of phenotypic revolution explains properly what has happened and how we get to DNA. He says there's the end of God dilemma on the origins of life, but he didn't take the time to explain much about it. I believe that what he refers to as the end of God dilemma is the fact that modern researchers who do research about the origins of life, they have to manipulate the molecules. They have to design their own solutions for observing what they observe in the lab. And so that's a human intervention. And it begs the question, what is it that intervened 4 billion years ago so that the original life form showed up? The end of God dilemma is really a critique of current research in the origins of life, and I would side with Saul on this. I believe that the current origins of life research is bullshit, and it is a scam. It is a bunch of parasites of the state who are draining money eternally to ask questions about what is possible rather than what actually happened. I believe we should totally dismiss these labs, we should defund them, and we should return the money to some effective use, because the origins of life community research as it exists right now is terrible. They have found nothing. I have found more sitting on a couch than they ever did. So it's bullshit, and I side with Sal on this one. He talks about the Spiegelman's monster. The fact that when we take lab-made RNA segments and we make them evolve basically in the lab, they evolve to reduce in size from 4,500 bases to 230. That makes absolute sense. In many environments, reducing the size of your genome must be the right strategy to win, and especially in an artificial environment where presumably everything that is environmental and natural is given by the scientist, and all that these strands of RNA end up competing with are the blocks to make themselves. In that kind of environment, you have created an environment in which the segments of RNA are incentivized at being as small as they can. As it turns out, this actually reproduces a real observation. For example, the mitochondrial DNA is known to reduce in size across evolution, and it's for exactly the same reason than when it happens in the lab. It's because a shorter segment of DNA is easier to replicate, and you can replicate more of it. Therefore, you have a natural selection advantage. But that doesn't mean that every single possible worlds and every environments of the past were pressuring for a smaller genome. Obviously, this would be impossible. There must be environments that push for larger genomes, and these environments are those where there is a relative abundance of the building blocks for RNA or DNA, but there is something else missing, and that something else is what evolution goes after. Could be better skills. 1 minute. Better skills to gather nutrition, better phenotypes in general. So the idea that some environment shows shorter RNA to be viable doesn't mean that all environments shorter RNA segments will be viable. Finally, quickly, he shows some math equations. He doesn't explain what it's about. I'd be happy to address his points if he explains it, but he cannot just drop equations like this and say, this proves you wrong. He says that natural selection seems to work, but what happens if all the creatures have a mutation? You can't eliminate everything. But that is the beauty of life. The mutations are not the same across all creatures, therefore, they can differentially reproduce and survive.
All right. Thank you so much, Jeff, for your opening statement. And now we will kick it into the 6-minute rebuttal phase. So I believe we'll go back to Sal for this 6-minute rebuttal. Sal, add your first word. I'll start your timer. I think you're muted.
I'm sorry. I have a slide. Thanks. This will serve as sort of a rebuttal. As a consequence of my last debate with Aaron Ra, he wrote me a letter. He says, proteins do not have an effing common ancestor. And he reinforced the point I was making. There is a problem with complexity and also independent ancestry of proteins, really genes/proteins. This is a diagram that kind of shows the independent origins. We can go into that. So basically, we have an orchard-looking model for the origin of major protein families, which is very similar to creationism. The problem is rooted in the complementary shapes of proteins. The spelling affects the shape and also charge distributions. They have to be very complementary. Geometry is priority. This is why mutations will generally be damaging. Random changes to a geometry will compromise the system. It's very hard to make improvements. These are just pictures. This is man-made puzzle. This is a God-made puzzle with proteins. And so the orchard model is there. We could talk more about that. It's like trying to evolve a car part from a single ancestor. It won't work even conceptually, even though morphologically it may make sense. I like talking about the turquoise polymerase protein. I had authored that. We can talk about complexity in that sense. My co-author had been published in Nature. I had the privilege of publishing with him. This will be great for the later on discussion. There is this paper, What's Wrong with Evolutionary Biology, written by an evolutionary biologist. Further, Jerry Coyne says, in science's pecking order, biology lurks somewhere near the bottom, far closer to the pseudoscience of phrenology than the physics. And whether he meant that that was his intended meaning, I would argue that, as said, that is correct. And he's ironically the author of Why Evolution is True. we can compare evolutionary biology to, say, physics, like physics of Maxwell's equations, from which we have modern day science. We wouldn't have this if we weren't able to apply electricity according to Maxwell's equations. This also leads, if we apply Maxwell's equations to the magnetic field of the Earth, we have something called Cowling's theorem, which shows that the magnetic field we don't understand, it shouldn't be there. And in fact, if you just go to the Wikipedia entry, it says the field will be negligible in about 1600 years. I mean, that would suggest if it does decay, this is also a testable prediction, although I may not be allowed around to see it. Civilization may see this decay. That would suggest the Earth is young. Now, to be fair, the rest of the entry says the strength is about average for the last 7,000 years. But if it does decay in 1600 years, we would have reason to think that we use circular reasoning to make this presumption that it was stable for the last 7,000 years. Again, it could be an illusion, just like this optical illusion. The pencil's not really bent, it's straight. It could be that the fossil record is young, and not really old. We have soft dinosaur tissues, and it's really the chemistry that's involved. The chemicals look young, and we're seeing this at all layers of the fossil record. I had done some work with various biochemists, including professor of biochemistry and organic chemistry, James Carter at Loma Linda University. We're finding ancient biomolecules all the way down to the Cambrian that are young. They don't have sufficient racemization. And so I've done shows on this. A lot of what I'm showing, I know I'm just blasting like a Gatling gun through this. I'm hoping we can cover this in the free discussion, Q&A, and possibly after shows, and people can visit my channel. This raises the question of radiometric dating. Just in 2021, there may be alternate methods of changing nuclear structure. If we have tectonic activity, this may be changed through the transmutation of elements through heavy electron quasi-particles. Great topic in solid state physics. There's also electricity can change nuclear structure. This is a 2017 paper. There's also a crisis in cosmology. These are headlines that I was seeing in 2019, even 2021, even now today with the James Webb Telescope. This is a forgotten paper just in 2021. The James Webb Telescope, this is a different cause for the redshift. And this will lead to possibilities of the variable speed of light. Again, Maxwell's equations, which will govern the speed of light, and Michelson-Morley. I worked through this equation here. It's on my channel where I actually made all my viewers suffer through this derivation in graduate school. And so just to say, I am serious about looking at alternatives for speed of light that will solve the distant starlight problem that has been plaguing young Earth creationists. Now, that brings up the question of God. If we just go purely outside of theology, but into science, specifically quantum mechanics, this book, Measurements in Time Reversal Quantum Theory, and then Cosmological Anthropic Principle, peer-reviewed scientific books, Oxford University Press, predict one interpretation of quantum mechanics leads to the inference of God. And also this essay in the journal Nature, July 2005. So I've tried to just frame this, people know that I have my theological thoughts, but we can kind of formulate a lot of theory of both old Earth and young Earth creationism in terms of pure science, theory, and observation. And thank you very much.
All right, JF, we'll go ahead to your rebuttal. That's your first word.
All right. I will immediately reject all appeals to authority, to the peer review system, to being in the official science that Saul does as a fangirl and cheerleader of this corrupted system. I don't care about what kind of peer-reviewed publication he publishes in. I probably published in better ones, and on top of it, I'm telling you, it's a scam, and it doesn't matter. The only argument that I take tonight are those that Saul can express. If you know something for real, you should know why you know it, and you should be able to explain it within 1 hour. I will also reject all this looking at the variable speed of light and Maxwell's equations. I'm not a physicist. He's probably just as wrong as when he talks about biology, but I don't know, and I wouldn't know how to point to his equation and show him where he's wrong. Now he asks some question about he says the fossil record could be young. He says we have soft dinosaur tissues, we have metric dating that could be erroneous. I'm open to the idea that radiometric dating could be erroneous, maybe by an order of magnitude, maybe by smaller margins. I think it's most likely smaller margins. But suppose we were wrong in radio dating certain fossils 1 billion year into the past, and it turns out to be 500 million years. Would that change significantly our view? No. It would simply be the case that we would squeeze what we believe has happened into a tighter window of time. Ultimately, you have to believe the theory of evolution based on basic observations of today's world. Doesn't matter if you don't believe the fossils or the radio dating. The fact is that complexity on this planet is accompanied by a feature that all living beings have, this possibility of reproduction, although some of them opt not to take it. Too bad. But all living beings have some form of device inside themselves that help them reproduce, and that most of them will end up using successfully. That is a feature of evolution. That is a feature of an evolutionary system. If God had created beings on planet Earth, he may have given them reproduction or he may have not. But evolution relies on reproduction, and the fact that everything that we see that's complex on this earth has been as this signature of having mutations happening to it, selection happening to it, and baby making happening to it, that is sufficient to believe in the theory of evolution, independently from whether you believe this has been going on for 1,000,000 years, 500 million years, or 4 billion years. So I'm not hung up on the details here. Our details of the past may change. Our story of the past may change as science gets better methods. I would be very surprised if it changed significantly. But it will still be the case that to explain why we have reproductive being on Earth currently being the only thing that's complex out there, because either we have rocks, volcanoes, meteorites, and these things don't act complex, or we have plants, mushrooms, and lions and tigers, and these things act complex. There is a reason why the category of thing that acts complex as reproduction, mutation, and selection. It means that this complexity has been caused by the process of reproduction, mutation, and selection, which is totally in line with what evolutionary theory shows us when we do it in model form or in lab form. He says the problem of proteins is that it's too hard to make improvements to a protein because of the complexity of 3D relationships between changes and morphology. So basically, the protein being a chain way too long and way too complex with way too many possibilities. And he claims that it is too hard to comprehend how you would have a protein change in a way that is advantageous. But life doesn't have to comprehend, life doesn't have to understand. Life tries different things. It tries different things out of pure randomness. And if any change to a protein leads to at least a life form that can maintain itself, then that change will be maintained in the gene pool. And so the replicators don't have to think in advance like human scientists. I understand that today's human scientists are incapable to look at a sequence of amino acids and fully conceive of
1
the
minute.
final 3D form of that protein. Now we have computers that are getting better and better at this, that are getting extremely good at doing it. But still, it is inaccessible to the human mind to do these processes, and it may be forever. It doesn't matter. What Saul would have to demonstrate to show that it's impossible, he would have to demonstrate that somehow the complexity of proteins is a level at which evolution stops to work. And this will be my last comment for this intro statement. We have to ask ourselves when we try to debunk a theory, what are the bounds of my proposition? Saul's proposition is evolution stops to work at a given level of complexity. There's some level of protein length at which evolution stops. But we know it's not the case because we know the mathematical structure of evolution. It will keep happening no matter the degree of complexity or length. Evolution always happens.
All right. Thank you so much, Jeff. And now we're going to go ahead and kick it over to the open discussion. But before we do that, I just want to let everybody know, especially if it's your first time with us on Modern Day Debate, that we are a neutral platform hosting debates on science, religion, and politics. And we want you to feel welcome no matter what walk of life you're from. And if you have a question or a comment for one of tonight's debaters, fire it into the old live chat and be sure to tag me at Modern Day Debate. Super chats will go to the top of the list. All we ask is that you please keep it civil, attack the argument and not the person, as insults will not be read. And that goes for the general discourse in the live chat as well. Please treat each other and their moderators with respect. Our guests are linked in the description below, whether you're listening on YouTube or via the podcast. So click those links if you like what you're hearing. Please do that right away. And hit the subscribe button. We have plenty more live debates coming your way that you don't want to miss, including on the 15th, we have Ken Ami versus Randolph discussing atheism versus Christianity, which is better for societies. And that's going to be at 7 p.m. Eastern time. And then one last thing just to mention is DebateCon 2 coming up November 19th in Plano, Texas. Tickets are in the description. The link for the tickets is in the description below, as well as the fundraiser. We're right now at 53% of our goal. We have 9 days left, and the tickets are as low as $25. So please, if you can be there, if you want to be there, please check it out, sign up, donate, whatever you can do. And with that, we will kick it over to our interlocutors for the open discussion. So, gentlemen, I will start the timer at your first word.
All right. I wanted to come back to a point where I didn't have a chance much to comment, but it's this idea of genomes decaying. To be clear, Saul, what do you mean by genomes decaying? Do you mean in length? Do you mean in talent, in phenotypic features like intelligence? What is it for a genome to decay?
First off, the basic unit is genes being lost. Genes being lost. And then when I was showing those geometry things, when the connections start to fail, and so even if the gene isn't totally disabled, like by, say, a premature stop codon, it may cease to function like we see in diseases.
Now, do you realize that there could be a ratio that there are more genes lost for a moment of evolutionary history than there are genes created? Do you acknowledge that this is a potential situation, temporary one, in a given environment that is possible?
I'd say it's possible. I don't believe it is highly probable. And if I may add just a little bit, I am seriously concerned about the human genome decaying, and this leads to something we both agree on or are concerned about. As far as I'm really concerned, my work and my advocacy, the genome's decaying, which is kind of tragic. This is a situation that's even the mainstream is saying we're decaying, and it may be pushing this whole thing about singularitarianism. I showed a slide on that. I'm not happy about that. Let me just say that from just a personal level. So it is a testable hypothesis. And then also I had the slides on decaying intelligence. Natural selection favors, women that are extremely high IQ don't have a lot of kids. 25% of them don't have children. So even outside, we can't actually, we haven't had the resolution scientifically yet to say what's causing the loss in IQ. It's also correlated with the speed of the nerve cells. So you could have something more objective than an IQ test. How are the neural wires functioning? And so that's what I mean by genetic loss. It could be also a phenotypic. It could be measured, but not as accurately with phenotypic loss, which is like example of loss of IQ. But that has a lot of environmental noise. We don't know how much, the environment. So I hope that helps clarify.
Well, my problem is that you are talking about two different realities, and I don't think that you have the same position on both. So first, there's the intelligence aspect, IQ. Okay, we will all agree that there are certain features of human societies that most people like, most people love, and what most people would agree losing it would be dramatic. That's one thing. But when you talk about losses of genes, like I think, for example, about a whale. A whale, let's say that if you were to accept that the whale has been previously a terrestrial mammal, eventually evolves to live in the oceans, and loses its legs, it would be. Are you saying it's a bad thing that the whale has lost the genes that create legs?
Bad and good are, I guess, qualitative things, and kind of goes on the metaphysical. And I prefer not to go there, even though I obviously have strong metaphysical opinions. We can actually count gene losses, and so unfortunately, I'm not very familiar with the whale, and I apologize for that. That's just not something that I study. So it's not that I'm dodging your question. I don't have a good answer for that. But for the humans, we do know, because we are studying heritable diseases, we know that humans have, we think, hundreds of human genes have been disabled. I mean, we see that across the population. So some humans may have them working well, some may have them disabled. So, like example, like diseases like Tay-Sachs disease, there was a messed up exon, and it causes the disease. So, I mean, you could say it's good or bad, but we know that it is a variant that seems to dysregulate capability. I mean, it's not good to have Tay-Sachs, as far as we know.
Forget about the specificities of the whale case. My question generally was, do you acknowledge that there are some losses of genes that are good, basically? Because to me, it was good when the whale found a way to survive for herself, but had gotten rid of her legs in the process. To me, it is good that some moles have lost their eyes, because visibly they are doing better without eyes because they dig so much in the ground. Do you acknowledge that loss of genes is not a bad thing in and of itself?
I have to make a qualified yes and no, and I'm sorry to be talking out of both sides of my mouth. For immediate reproductive success, it will help survive. There are modes where it's just like amputating a leg. Sometimes you got to do it in order to have survival advantage, and we can kind of say that at the population level, we're losing genes. We see that in the pangenomic profiles of bacteria, that 80% of E. coli is conserved. That means they can get along without a lot of genes. Lenski's experiment showed that gene loss led to advantage. Again, this is echoes of Spiegelman's monster. We're seeing that where it can be beneficial in the sense that it's reproductively advantaged. The trade-off, though, is it loses versatility. So it might be specialized for that environment, help it to survive in the struggle for existence in a very hostile environment, but it will lose versatility. So the question is whether it can reacquire anything to compensate when it gets into another environment. Otherwise, it's going to die. So that's my view. So I will agree, yes, it will help it survive. I would have to say that the loss of versatility actually puts it at risk long term, and that's where I think that evolution fails, because it's so hard to recover a gene once it's lost, or anything that will compensate.
Well, I tend to think that genes can have resurgence simply because when they become inactivated, when a single mutation inactivates them or a couple of mutations, they still stay in the genome for a long time. For example, we have bacteria like Escherichia coli, as it is said in English, that have basically genes that are just like the legs of the whales. They show some signs that they were there, and the coding for these genes, although they are not expressed, we can see that they were there in their ancestors, but they got crippled by various mutations and they are not functional anymore. So I think that the resurgence of a feature in evolution is a thing, and it can happen, especially if you have had that features not so long ago. So to me, if it is beneficial for life forms to lose genes, I don't take issue with this. Sometimes you just have to carry less weight, you just have to cost less in terms of nutrients, and therefore sometimes the best thing you can do to survive is get rid of some genes. And anyways, the world is changing constantly, so you wouldn't expect that the genes needed to survive today with a new organism are the same that were those that applied to your ancestors. Now, I wonder, given your view of the world, it seems that you are giving credence to the young earth creationism type of crowd, at least as a potentially true theory. How would you explain the resemblance of the ribosome across all life forms, from bacteria to mammals, let's say?
Well, thank you. And if I may interject a little bit, just for the sake of the audience that might be curious, I used to be a theistic evolutionist, became old Earth creationist, young Earth creationist. So the problem is the problem of similarity that is dogging young Earth creationism. That's why old Earth creationism is a little bit more popular. We can account for similarities, just like you said, the ribosome across all species. I see proteins that are shared across all species, and then some they call orphans or they're names for those taxonomically restricted. In a young Earth environment, it wouldn't be the result of common descent. It would have to be, as a matter of principle, common design. And I had suggested in my last debate, the reason for this is optimality for scientific discovery. So when we talk about anthropic principles and the reason why the universe is structured the way it is, two things come out. That it seems the universe is optimized for human life. The solar system is especially optimized for human life. Our star, the sun, is unique in all the universe as far as we know. It is very, very special because of its stability. And also it seems we're in a privileged position in the universe to do scientific discovery, extending that kind of anthropic viewpoint for both habitability and scientific discovery to life. It is very providential, in my opinion, that we have all these creatures we could study to understand ourselves. So my explanation is God did it so that we could understand ourselves. One thing, and I wanted to compliment you on your defense of the unborn, and it is also my feeling that it is good that we can study creatures as model organisms, so we don't have to do experiments on human fetuses and do embryonic stem cells, that we gather from that. So that is my answer. That is not really a scientific answer, except to say if it's young, it's a matter of principle. It would have to be by design, not common descent. The reason is a metaphysical speculation, and I'm saying it as such. Also, in my protein research, we're finding that the differences in sequences between proteins across species helps us to do fold prediction, which seems to me not to be random. We could do fold prediction. We have this in AlphaFold a little bit more in what we call direct coupling analysis. Some of my work in what they call the K-modes algorithm is kind of trying to supplement that. And I just think this is an interesting pattern. If, for example, and this is a testable prediction I'm trying to work on, if we didn't have the plants, our fold predictions would fail. That would tell me that the pattern of similarity and diversity is not an accident. It seems to have been implemented by foresight. That would be a young Earth creationist view. I'll be the first to say that there are challenges with the young Earth creationist view, although I definitely accept it for theological reasons at this point in my life. Then I'm not saying that it's prime time, but that's about the best answer I could give. Thank you. Thank you very much for asking that. It's a great question.
Well, these K algorithm being fooled by the absence of plants or the presence of plants, I think it's not particularly surprising. Those are algorithms that try to cluster things, and if you give them no cluster to contrast with, it would be expected that they would be fooled. So I'm not surprised at all that when you remove some information acquired from the real world, those algorithms end up giving you a false picture. But that's precisely it. The plants are giving us information that we should include in our science, and they are giving us a contrast. I find it amazing personally that the plants have chloroplast and mitochondria when we only have mitochondria. That is a super important fact for how we evolved and what is the history here, because you cannot have a history where the chloroplast was not in us and was in plants. You cannot have a history where there's no path for them to acquire the mitochondria. So it strongly limits the kind of tree of life that you can think about when you know just one thing about plants. Now, when you say stars are optimized for human life, I believe that you are suffering from a optic illusion, simply because evolution leads life forms to be adapted to their environment. You seem to acknowledge this. And so wouldn't the prediction be the general expectation, your default expectation should be that whatever life form survives even a small amount of time will end up showing features that are biased to look like the world is made for them, but rather it is them that are made to survive in their world.
I have a counter to that, but it's not very well stated, articulated at this time. It is something that was, I mentioned one of my publications also, where we addressed that. So I'm going to fumble in my response to you because that's a very, very good question. The thing with the solar system, we know it's unique statistically, independent of life or no life. But a sun that is flaring and have high temperature variations, that's not conducive to the operation of machines. I don't know how you feel about characterizing the parts of life as machines.
Well, then you didn't read my book.
I didn't read it. I skimmed.
You bought my book, but you read it. You didn't read it.
I didn't read it in detail. I only had 2 hours to prepare. So, but I bought your book. You can look at Amazon. You could see I paid $9.99 for. So I felt it was a good cause. I almost never. You're the first person I bought the book for my opponent. That's how highly I think of you.
Oh, wow.
So I'm sorry. Okay, so I flunked your question there.
Yes. So
I flunked that part. Do you have a view of life being machines or not?
Yes, I believe we are machines. I'm a physicalist. I believe we are the set of atoms and quantum fields and whatever that we are. I don't believe in an alternate dimension in which our spirits exist or whatever.
Okay, so going back to your question about that, I was just saying in terms of, from an engineering perspective, whether we call it life or not, let's call it operation of machines. We would prefer that the environment not be too variable. So when we engineer things, it's like a predictable, stable environment is nice. It's like, if you're building kites, you don't want to have too many tornadoes when you're flying it. They're operating parameters. And so the star is definitely special in that sense. So adaptation, the view of adaptation in evolutionary biology versus the way it's conceived of in engineering are different enough. It needs to be borne out. There is the book Survival of the Sickest, where, like I mentioned, Tay-Sachs disease and even sickle cell anemia, diabetes, obesity have been considered adaptive traits. From an engineering perspective, this is like, that's actually not very, there's something that feels unwholesome about that. So the way that we define kind of suitability of a machine for a given environment, like a submarine is optimized for the sea because it can, it's not optimized to operate like, say, in the desert. So we would define the adaptiveness of a whale from an engineering perspective in terms of its physical machinery, capabilities, materials, etc., and not in terms of reproductive success. And I think that leads to an equivocation a lot in evolutionary biology of what adaptation means. In fact, it was Lewontin, and this is something we covered in our publication, and all we did was just scour evolutionary theory and just summarize what they said for our reference work. There was not a lot of original work. And I was shocked that Lewontin said fitness is not well defined. We don't know exactly what it is, because he said it's really nothing more than the reproductive schedules themselves. How much more insight does that actually add? Whereas we look from an engineering perspective, the suitability of a machine operating in a given environment, you come up with different parameters. You don't get just kind of one figure of like, what's the reproductive success in terms of, fecundity and viability. um, you look at the suitability and the materials and the organization of the parts. And finally, I do recommend JF's book. So here's a free plug for your book. I enjoyed reading it. Your writing style is very delightful to read. And I do apologize for missing what you said. But I did like I think if I got this right, there were three phenotypic revolutions and one predicted that you're kind of worried about. And that's one that I'm also worried about. If I may venture a question to you, I'm very concerned about this idea. I mean, do you have any, I use the word singularitarianism, and I'm concerned that my work on genetic deterioration is going to be used to kind of fuel this, and that bothers me. John Sanford is very much against genetic engineering, and I know we're going a little bit off topic, but I was just dying to ask you this. Is that what you were referring to, like Ray Kurzweil's book about the singularity? Is that something you're against? Because I'm against it too.
I can reassure you, I believe that you shouldn't worry too much about the singularity. Now, I do present a scenario in which computers take over, but as I say in my book, it will only be through modifications of the human genome. In other words, as long as it's a Ray Kurzweil type of computer, where it's a more and more intelligent machine, it cannot take over the evolutionary interest of humans. And so you have in evolution the key to why we can protect against a singularity. It's the fact that there are always humans who are going to hate computers, and there are some who will be computer loving. So if a very intelligent AI shows up and starts manipulating the world in his interest, there's either of two things will happen. Either he's actually going to help humans survive, in which case we will evolve to like it, or it will not help humans survive, in which case we will evolve to dislike it, to ignore it, and eventually to shut it down. So that's why a singularity cannot take over humanity, because people can evolve to be arbitrarily stupid or arbitrarily intelligent, to stop listening to this AI or listen to it when they care about it or listen to it when it's good for them. That being said, when you undermine the evolutionary system of humans, when you start attacking sexual reproduction, when you start modifying people's genes, that's where you create a mess, because evolution doesn't allow you to escape the mechanism of control anymore.
Well, thank you very much. So going back to our topic, if I may venture this question. So you see that we might have slightly different views of what a good mutation or beneficial is. So just kind of in terms of genetic units, are you aware of any new proteins that have emerged, like say, since we actually started to know the structure of DNA, do you think humans will start to evolve new genic units, a new protein family? Do you have any evidence of that?
Absolutely. I'm thinking of the furin cleavage site of SARS-CoV-2. This was not on planet Earth more than 2 years ago, and now it's there. So here you have the example of a life form that has found a tool to somehow trap our cells better and attach to them better, or enter the cells better, and it has led to much spreading for this life form. So yes, there are new proteins that emerge.
I mean, as far as, so this would, I'm sorry, what was the name of that protein? SARS-CoV-2?
SARS-CoV-2, the furin cleavage site of the spike protein.
Okay. I hope you don't mind. I'm taking notes here.
Oh yeah, I mean, it's every time you hear of a new virus that wasn't existing before, probably this virus has a new feature, and probably it's some new protein or some new shape of protein that makes this virus different from the ones we knew before. Now, it doesn't mean that the virus doesn't have ancestors. To the contrary, I believe that SARS-CoV-2 has a series of ancestors that dated back 4 billion years into the past. But those are examples. Any new virus, any new disease that has new features are all examples of evolution happening in front of our eyes. And it's not random that this particular SARS-CoV-2 virus turned out to have a furin cleavage site. Apparently, it's what may make the disease more aggressive compared to your usual coronavirus.
So I was specifically mentioning the human genome. So it would seem, I mean, I don't think that the human genome can do a lot of it, as much experimentation as, like, say, the viral world in terms of generating new forms. So again, correct me if I'm misunderstanding your viewpoint. It would seem to me that it's not going to be happening in the human genome to create really a new protein family. We can recognize protein families statistically with this position-specific scoring matrix system in the variety of all these bioinformatic databases. So if it's just like a point mutation, it can still recognize that as a homolog. So when I say a new protein family, it'd be something that would fall outside of these little islands that we can even see very clearly.
Well, by definition, you're looking for a new protein that would come from nothing, that would be absolutely novel. So by definition, you are excluding the reality that you're looking for. But there are plenty of examples of extremely rare mutations in humanity, and yet in 100 years from now, they could be quite common. The only question is it going to pay off to have that mutation? For example, we have the evolution in response to malaria in Africa. We have humans that develop a kind of defect of their red blood cells so that they are less good cardio-wise, but they can defend against malarial infection. So we know that evolution can happen in human, but you're asking on a scale of time of 100 years. Well, what's 100 years for humans? It's about 5 human generation at best. So you're not going to get much evolution, certainly not the creation of a new category of protein over 5 generations.
Yeah, well, I'm of the opinion it's not going to happen. And unfortunately, we won't be around to test some of our hypotheses. Our lifetime is just too small of a sample size, and we don't have enough history of data that was collected, because it's only now that we have some capability to examine the genome. And so we are left with speculations. I obviously have expressed my biases. Where I have felt just personally that there had to be a big leap of coordination is in the emergence of eukaryotes. And when I pointed to that protein orchard, there's no effing common ancestor. That was what Aaron Ra. The point is, he and I are ironically in agreement that the proteins are an orchard, but he didn't see it as a problem for evolution. What I saw as a problem for evolution is the emergence of the chromatin, particularly the chromatin that is in eukaryotes. There may or may not be some in archaea, but when I saw the number of simultaneous proteins that had to be present to implement the chromatin, which is, you need chromatin remodeling to be able to do double-stranded break repair and also to do gene expression, all the remodeling and all the machinery that had to be there in place. For me, it's easier to believe in miracles. That's where I am. I mean, obviously people don't agree, don't share that view, but that's one case where slow mutations over years is just not going to work. For transitions of that magnitude to happen, it would have to be instantaneous. And from a statistical standpoint, from my vantage point, this would be indistinguishable from miracles of God.
Well, I think that the fallacy you're committing here is to think that because a system is currently complex, that each of its past iterations had to be equally complex. Putting together the chromatin of today's DNA may involve 100 proteins or thousands, I don't know. And yes, if you mess with any of these systems in the modern world, you will fuck up the whole thing. You will mess with it in a way that will be dysfunctional. That doesn't mean that there were no prior form that could have accomplished a similar work, or at least a partial work that gave a similar advantage. For example, the ribosome that we look at in mammals, for instance, is much bigger. It involves a lot of protein, of subproteins that get together, a big package. It's basically a big manufacturer for proteins. We know that the elements that do the protein fabrication within the ribosome are very small, 2 strands of RNA that can be reduced to 70 to 90 nucleotides each. And we know that these 70 to 90 nucleotides are able to accomplish the task of going from a strand of RNA into a protein. So you don't need the big thing to accomplish some amount of work. And that's what I think you need to understand. There may have been proto versions of chromatin that didn't require the current complex systems that make it.
My criticism of that is this is relying on an extrapolation and faith, and that's fine. I mean, because this is trying to predict the origins is speculative, and the reason we have debates is it's not clear what the truth is. There's not a lot of debate in mathematics over accepted theorems, and also basic chemistry. When we deal with the past, there are so many uncertainties that sometimes we do have to fill in the speculations with kind of our intuitions and faith. And so I'm not faulting, because I obviously have faith in how it happened myself. So I'm not singling you out for that.
It is not faith, though, to say that something is possible. It is
Yes.
not faith. It is a statement of compatibility between a mathematical structure and a possible reality. It's very different from saying, I'm sure that chromatin had a protoform to it that used only one protein. We have to establish what we're talking about here. We're talking about whether evolution could explain the current world and whether it's the better explanation. Now, those two separate questions, sometimes a matter of possibility will answer the first, but not the second.
I have just two questions. First one about peer review. Next, whether you want to go to the question and answer of the audience, because this is being a very nerd discussion, and I'm afraid we're putting our audience to sleep. They probably were hoping for more drama. This is one of the most delightful interactions I have. I really don't like all the theater, this sort of theater. I like theater, but not confrontation like this, especially if I respect the opposing side.
1 minute.
So I loved what you said about peer review. So this isn't really a question, except to say if you could elaborate. I kind of love what you said because it resonates with me, having to have fought with the peer review system myself. And I thought some of it's a scam. And I was really astonished. You said the origin of life, you think it's a scam. Do you have any feelings about if there's scams in evolutionary biology? I know you're going to step on some toes, depending on how you answer. I would appreciate hearing from you about that.
Are there some scams? I mean, yes, there are people who have literally been exposed for having published completely fraudulent histories of facts, including Mr. Hauser, Dr. Hauser from Harvard, who made up things about monkeys and what they could do to justify to justify a kind of evolutionary view of intelligence, but he was over-representing their intelligence as part of this. So yes, there's definitely plenty of fraud. As far as peer review, the issue I take with peer review is the fact that it's a gatekeeping system for scientists who are young and who can come up with better than this system can do. For example, I think that my theory couldn't have been accepted in peer review because the old scientists who are controlling what people see in peer review, they have to block any material that they don't understand or that's too creative for them. And this leads to a conservatism in the advancement of science. So I don't like it. And I think we should develop an alternate system for communication of science. And this goes through open publication and books and theorizing, and certainly not asking for permission to an old scientist to publish something.
Oh, thank you.
Well, thank you both so much for that riveting discussion, and we're going to go ahead and move it to the Q&A now. But before we start asking those questions, I just want to remind everybody once again that our guests are linked in the description below. The debaters are the lifeblood of this show, so if you like what you heard tonight from either of our debaters, please go ahead and click their links below. I want to remind everyone about DebateCon 2 once again, November 19th, Plano, Texas. Tickets in the description below. And with that, I'll go ahead and start the... Oh, yeah, one more thing. There's going to be an after show tonight on my channel. Both of the debaters have graciously accepted my invitation to join me, so we will continue the conversation afterwards there. So with that, we'll go ahead and go to the Q&A. First question is coming in from Big Bad Mama for $2. They say, James, please... Oh, sorry. Yeah, that was a question that they sent a super chat to get me to see there. non-super chat. So that question was, Sal, why is intelligent design still synonymous with Western fundamentalism and largely ignored by the global academic science?
I don't know. It's not really my concern, but people, Western, I prefer the word evangelicalism because it resonates the idea that there's a creator, and that's one reason. There has been a growth of intelligent design in the Muslim world. Why is it rejected by academics? I think the fundamental reason is evangelicals are willing to believe, Christians in general, people of religious faith, believe in something they haven't had direct experience in. Or, for example, I don't believe in Zeus or any of the deities of the ancient Greeks or other cultures. And it's because I haven't seen those deities appear to me. And so a lot of people who matriculate in the sciences, they want hard facts, and they want to see things that they can test in the lab, understand, and control. And to be a religious person, you're willing to accept maybe some deity that you can't apply all those things for. But intelligent design has argued that this is so improbable. It lends credence to the idea that there is a creator. That's certainly what happened to me. I nearly left the Christian faith 20 years ago. And when I saw the intelligent design arguments and the statistical stuff, because I'm very math oriented, I felt that the life is very far from natural expectation. Therefore, it seemed like there was a supernatural cause. Thanks. Nice to hear from you, Big Bad Mama. Nice to hear from you. Thanks for being, we disagree, but she's been in my fan club. Nice to hear from you again.
Got it. Okay, from Samar Rao for $9.99, they say, Sal fundamentally misunderstands the theory of evolution. Quote, keep the best, toss the rest, isn't an accurate view. The good and bad genes are advanced through time together as a package.
No, thank you for your observation. Keep the best, toss the rest was actually the policy of a horticulturist turned genetic engineer. That was my boss. So that's just a term that he used to, we were in the garden together, and he was saying, Sal, you got to have less plants. And I was saying, well, this makes my mom so happy. He said, you need to get rid of them. You need to do more work. Stop doing all the gardening and get to work. And I said, okay, so have you, how did you do it when you were a horticulturist? He said, I tossed maybe 98%. But keep the best, toss the rest. That is a figurative way. But if you look at population genetics, which I've written on, and that was like that Springer Nature thing that I showed, it is kind of that. It is keep the best, toss the rest, where best is defined by reproductive success, fecundity times viability. So I think I was actually accurate. That was just a figurative way of saying it. And by the way, you were correct in saying, are they good or bad genes? Good being like function, could it be a defect? For example, like something that causes you to lose vision, just the example that JF had pointed out, where there are creatures that lose vision. So the best in that sense, in the population genetic sense, is the reproductively successful. It does follow that keep the best, toss the rest. But that is, that really holds when you have strong selection pressure. There's sometimes where that's not true. The neutral evolution theory kind of shows that, where you can actually fixate deleterious mutations in a small population. I know I'm getting really technical. Anyway, I'd like to offer, if JF wants to comment on anything I say, I'd like to give him that freedom.
Well, yeah, but I think I think that your view as an engineer of good as optimal is what leads you to misunderstand biology a lot. I think when you consider diabetes and diabetes is not good, diabetes, if it is a bunch of genes that make you a little more fat, and you happen to have had in your history a lot of living in European countries with cold winter, it may be a trade-off that's worth aiming for, especially since diabetes tends to develop in older age. You will have had the chance to reproduce before you die of diabetes in an evolutionary context. So understanding these trade-offs is very important before you say that's because something doesn't look optimal to your engineer eye, that it is not good evolutionarily.
Thank you.
Okay. You want to have the last word, Sal, because it was your question?
Just briefly, there's a beautiful video by William Bialek, Princeton University biophysicist. He said life is more perfect than we ever imagined. He talked about the optimality in terms of physics, particularly sensory organs. So we are seeing, it is amazing. An engineer would love it. And it's hard not to have that, my engineering viewpoint sustained in my perspective of biology when I see lectures by a preeminent biophysicist. So thank you.
What was the name of that quote that you said, Sal, just a second ago? Sorry.
More perfect than we imagined. Just Google more
that?
perfect.
All right.
Bialek, by more perfect than we imagined. William Bialek. Was that what you were asking?
Violet. Okay.
Bialek.
Got it.
William Bialek.
Thank you so much. Okay. Question for JF from Anomic for 199. They say, JF, which came first, the chicken or the egg?
The egg.
Okay.
Because there were reptiles having eggs way before there was any chicken.
Okay, perfect. And
good answer.
Next question. Coming in from Samar Rao, once again for 999. They say, JF, is the fact that DNA is progressively getting smaller detrimental to the selfish gene, i.e., individual genes being smaller is more likely to conserve them during crossover or mutations?
No, I don't think it's detrimental. I believe that ultimately you have to understand, even under a selfish gene perspective of Richard Dawkins, he understood that ultimately the genes are collaborating under an umbrella of interest. That ultimately, even if they are selfish relative to one another, the genes for your brain cannot survive without the genes for your heart. And life behaves as if it knew this, because it won't sacrifice your heart all of a sudden. It's kind of established in our genome and in the way it mutates and evolves that there is an interdependence between all genes. So I don't think that shortening of genes is worrying for the theory of evolution. It's simply that, yes, at some point, if you have good genes and you have bad ones, you have an interest in shorting a little bit and in getting rid of some of it if it impedes on your reproduction. And the moment it will impede on your reproduction is when it has too high of a nutrient cost, or when it starts hurting your cells or making it not practical for your cells. And at that moment, you counter-evolve and you shorten your genome. And at other point, it will expand. I mean, we know of chromosomal event that can just totally change the number of DNA bases in your chromosome set, and it's massive changes all at once. So let's not forget that mutations are just one way in which the genome changes.
Okay, perfect. And the next question is coming in from Samar Rao from 499. They say, to both, do you think abiogenesis in some form happened? Why or why not?
Sal, you want to go first?
Sure. Well, obviously we're here. The question is it probable with an expectation? I would say it's outside of natural expectation. Therefore, I would say it's a miraculous abiogenesis. And by the way, thank you for everyone for their super chats and donations. I forgot to acknowledge you all. Thank you for the questions. That's all I have.
All right. Well, I think that abiogenesis is not super hard to imagine and to see, in fact. Things not being a replicator and suddenly becoming a replicator are all around us. It happens in the crystal structure, even just of a block of ice, acquiring new drops of water, and eventually the molecules align into a crystal. Just this change in the molecules from a liquid state to a solid state is a form of reproduction, because the form, the morphology of those that are already crystallized eventually is exported into the morphology of the newly crystallized water. So, and there are many examples of self-sustaining chemical reaction that produce their own input. Chemical reactions that will produce heat and that need heat to keep going. Fire is one of them. So it's inevitable that our world is filled with things that keep going on after starting. And that's just what life is. Now, our particular form of life has attained an amazing degree of complexity that differentiates us from the fire and from the ice. But it's not hard to imagine a transition between something that doesn't cause itself and eventually becoming something that causes babies, offspring, or copies of itself to wander around the world.
May I get in a second word, if that's okay with you, JF? Thank you. What is special about life is that it's a violation. Many of the macromolecules seem to be a violation to me of large numbers. I've been briefly a professional gambler, and the law of large numbers and violations of that are very heavy on my mind. You could see this. There's a book by Change Tan, Rob Stadler, The Stairway to Life. They talk about homolinkage in the RNA molecules. To me, that's a big violation in the law of large numbers. That's why I think there has to be a supernatural agent, some sort of miracle. The alternative is a violation of physics that didn't have anything to do with God, but still it would be something that we won't have any access to in the present day scientifically, as far as I know.
Well, I reject this as a violation of large numbers, but you say you were a professional gambler. Did you go to the World Series of Poker?
I'd be a terrible poker player. I was a blackjack player. If you go to Mind Matters AI, a whole month this summer was spent on me talking about my gambling adventures on an artificial intelligence channel. And a lot of large, so blackjack. Yeah, that was. I'm not a poker face. If I had a good hand, you'd see it right on. My eyes would just light up. I would totally lose. I've been kicked out of so many casinos. That's why I ended up doing science instead.
Excellent. All right. Next question from Samir Farsain for $5. They say, kinesin proteins walk on two legs inside a cell, carrying huge loads with two arms. If stuck, a second kinesin comes to help. How do these atoms learn labor?
Well, they don't learn labor. There are some versions of them that may not do this, and there are some versions of them that do this. And those that do this end up outcompeting and being the only ones you observe. So it's through competitive advantage, simply. The molecules don't have to understand it as helping or as labor, and they don't. All they have to do is do whatever the laws of physics imposes on them, and they will get selected if they're efficient for the genes that created them.
Got it. And from Cameron Hall for $1.99, they say, Sal, can you name one testable prediction made by creation?
I can name two. Cowling's theorem predicts an interpretation of Cowling's theorem. Geomagnetic field will decay in about 10,000 years, which would lend credence to young Earth creationism. The next is genetic deterioration of the human race. Even evolutionists have said less than 100,000 years. And that would, again, the credence to young Earth creationism, because if we are dead in 100,000 years, how did we evolve from primate ancestors over millions of years? So thank you very much for the super chat and for the question. That's a great question.
Okay, thank you so much. And the next question from Samir Farsain for $5. They say, mathematically, the universe itself isn't old enough to randomly arrange 10 billion atoms into a single chromosome, trying one combination per second.
Well, you don't know this because you don't know what's the total complexity of the universe, and you don't know the number of attempts that have failed and the number of attempts that have worked. And you don't even know the number of planets on which some amount of replicator has emerged. So you don't know what you're claiming there. You don't have the probabilistic knowledge of what you claim.
If I may, JF, this goes again to the law of large numbers. To be able to have chromosomes and all, you need homochirality to be expressed. It brings stability and readability. And we can calculate things that deal with the law of large numbers. The statistics for an actual chromosome is a little harder. I go at a more basal level at the origin of life chemistry for forming, polymerizing RNAs, DNAs, proteins. So I think your statistics are correct. It is a violation of the law of large numbers. That is one reason I'm a creationist now, is that's the kind of math I feel comfortable with.
You can take any system that's complex and claim that it's improbable. I mean, you could take a rock and count the number of atoms in it, and you can count the number of ways these atoms could be configured, and you would realize that this rock is extremely, extremely, extremely improbable. That doesn't mean the rock isn't there, and that doesn't mean that the rock must have been created by an intelligent being. It just turns out that any special configuration of the universe of any kind is extremely improbable because there would be large numbers of other possibility.
Got it. From Damian Martinez for $4.99, they say Jesus came to proclaim the true creator. If he was a historical figure who many Christians died for, how is this not evidence of God? That's for you, JF.
Well, can you repeat? I thought it was for Sal, and
Yes.
I wasn't paying attention.
Jesus came to proclaim the true creator. If he was a historical figure who many Christians died for, how is this not evidence for God?
Well, it's not evidence for God in the same way that if I start claiming that there's a spaghetti monster in the sky, it's not evidence for a spaghetti monster in the sky. Humans are deluded. They will tell you all sorts of bullshit. You shouldn't listen to them. You should only listen to the people who can explain to you how they reach their knowledge. And Jesus didn't.
Damian Martinez, thank you for the super chat. For me, I feel that I have personally experienced answered prayers. I have friends that I consider trustworthy. Astronaut Charles Duke prayed for a girl who is blind. She got healed. I have reason to believe him. And that's good enough for me. It gives me hope. And it's nice to hear from you. And thank you for your super chat. And thank you for all your moral support on my channel.
Got it. Thank you. And JF, did you want to say anything else, or you're good?
No, I'm good.
Okay. From Samar Rao for $4.99, they say, thanks to JF, both JF and Sal, for a fascinating discussion. Kaz and James as well.
Thank you. Thank you for your super chat and for the kind words. I think this is the best debate I've been in a part of ever here on MDD.
Definitely. Love modern day debates. Thank you to James. And I'll say that again later. But yep, thank you, Samar Rao, for the super chat. From Autistic Atheist for $1.99, they say, Sal, is creationism based on human exceptionalism?
I wouldn't say that's foundational. I would say creationism now is based on first the origin of life being improbable. I'm trying to advocate for eukaryotes being, special. The universe is exceptional. That's fine tuning, and then now also the solar system. So those are the big pillars of both young and old Earth creationism. Human exceptionalism is, I would say, just an add-on, and we are exceptional. I see that when I look at the post-translational modifications of our genes that are homologous to everything, yeast all the way up to mice to humans. Humans have like 5-10 times more post-translational modifications. We are very sensitive to deviations. That's why I think our genome, sadly, we're going to be losing intelligence because the fragility, we're so deeply integrated. We have capabilities that are just amazing. We are exceptional in terms of our intelligence, but there are capabilities that are also exceptional in other creatures, like the Arctic tern. Pre-GPS, you could use the magnetic field to navigate from north to south. So human exceptionalism, it means in what dimension? I would say intelligence is our dimension, but in terms of sensory organs, I think there are other creatures that are more exceptional than us. Therefore, I don't use it really as a basis for creationism. Great question, and thank you for the donation.
Oh, Sal, now that you mention eukaryotes, I realized that I forgot to bring a point to you. I think I have an answer to your question about why would there be introns and exons. Would you like to hear my theory?
Oh, actually, That is a eukaryotic feature, but I don't think I put that on the table. I was talking about
No,
double-stranded
you
breaker
didn't.
fork.
I know you didn't. But I
But
heard
yes,
you talk
please,
about.
please.
I heard you talk about introns and exons in some other debate or some other channel,
Well, sure.
and I
Thank
thought
you. Yes, I would love to hear it. So please.
I believe that if you take into account the theory that the nucleus of eukaryotes has evolved from a viral infection, a viral control of an RNA-based organism, that is, you had a DNA-based central command center that was living beside a cell, eventually entered into it, became the nucleus. I believe that it would make sense that there are introns and exons because it would mean that there is a war between the viral organism and the bacterial organism that it was trying to infect. And the bacteria was trying to defend against bad genes for it, whereas the nucleus was trying to inject genes that are good for the virus. So if there was a war between the nucleus and the rest of the cell at some point in our evolutionary history, it would make absolute sense that we have introns and exons.
Thank you. Though obviously I reject it. I think that's better than what I've heard from peer-reviewed literature. So bravo.
Okay. From Stephen Mulraney for $5, they say, JF, wouldn't you agree that memetics is a huge scam around biology, relevance to dual
Absolutely.
inheritance thinking, etc.?
If you want to see the scam get destroyed, read chapter 9 of the Revolutionary Phenotype. It's the end of memetics. I signed its death certificate.
Okay. And from the Great-Eyed Yam for $2, they say, any thoughts on Gödel's incompleteness theorems?
Well, the Gödel incompleteness theorem is the idea that any set of axioms will have will lead to certain statements that are true, but that are not provable in a system of mathematics or theory of any kind, of any degree of complexity. So I agree with it, but at the same time, it's something that is so adored and so amplified. In the end, it's just a simple result, and I don't think it matters all that much. I don't think it's as deep as it is made out to be.
Okay.
Okay. Well, no, just briefly, that inspired me to think there are certain truths we can only accept by faith. It may be true, but beyond provability. That's, that would obviously resonate with religious people. So that's all.
Yes.
Okay. From Mike, who's a member for 2 months, they say, thank you to JF and Sal. You guys got a fan out there.
Thank you.
So,
thank you very much.
From Bitter Truth for $5, they say, Sal Cordova, can you provide me your creation model, how God creates this universe through the Bible?
I don't think the model, I'd say no in terms of scientific principles and the laws of physics. So usually models like, say, orbital mechanics, you'd take laws like celestial mechanics, you'd know the initial conditions, and then be able to draw things up and make predictions, and also retrodict how it behaved in the past. You can infer it. With the creation model, whenever you have anything that involves miracles, can you call that a model or not? And just to be safe, I would say miracles are outside of scientific inquiry. However, if we infer miracles in the past, we might be able to make testable predictions, whether we're putting them in the right space in terms of chronology, history-wise. I gave 2 testable predictions that are unfortunately beyond our lifetime. Fortunately or unfortunately, one of them's the human genome's going to decay. Thankfully, it won't be around to see the idiocracy evolve out of our present state. And also Cowling's theorem and problems with the geomagnetic field. The geomagnetic field decays in 1,600 years or 10,000 years. Our atmosphere will start to sputter off from the solar winds, and there won't be much left anyway for us to cheer about. So, on some level, I hope I'm wrong, but that would be kind of my model as far as the consequences. But the actual mechanism of creation, I think, is beyond the reach of science and mathematical modeling. That's the nature of miracles. Thank you. That's a great question.
Okay. And from Coffee Breath for $1.99, they say, by what mechanism did God's voice manipulate matter?
I'm pretty sure that's directed to me. And that's basically, thank you very much for the super chat and the question. I think I sort of answered it in the last. I think when they said God's voice, I think that's figurative. It's really God's action, his miraculous power. It's saying that what he wants and he declares he gets because he's God. And I did mention this book here. So if you look at the quantum mechanical God, he would have those powers. And if you'll indulge me, let me just read here. It's beautiful. Omnipresent eternal personality, which is omnipresent in taking the decisions that are left undetermined by physical law, exactly what in the language of religion is called God. We thus see how quantum mechanics theory requires the existence of God. And that's about the extent of how we can describe God in miracles from a scientific perspective. There's just not going to be a lot of details. Great question.
Okay. From Bitter Truth for $5, they say, Sal, please show us Adam or Adam/Eve fossil and how old humans on this planet are according to the Bible.
I don't have a good answer for that. Thank you for challenging me, and I think it's great to be skeptical. As I said, if our genome's deteriorating very fast, we can't have been around very long. That's an indirect evidence of Adam and Eve. There are some studies with mitochondrial Eve and Y chromosomal Adam, but I take molecular clocks with a big grain of salt. I don't know that they're very reliable, but to the extent that we've seen it, there is at least an outer bound of, say, 200,000 years for Eve, depending on how we clock it. I would argue that, it could be less than that. I don't know that we can get to 6,500. Some papers by Parsons suggest that it is 6,500. Y chromosome Adam is going to be a lot harder. So I don't go from the science. There are a lot of creationists that start with the Bible and then try to do science. I've been kind of the reverse. Like I said, I was a theistic evolutionist. I try to go from what little we have in terms of science and then build a model. And right now, that model seems closer to me to what the Bible teaches. That's one of the reasons I believe it, in addition to answered prayer and miracles. So thank you for the question.
Okay. From Samir Farsain for $10, they say skills aren't passed on through DNA. How come my orphan dog knows to bury his bone for later retrieval? Breeds of birds sewing leaf nests with thread. Their parents did so before they were hatched.
Because skills are passed through DNA.
Okay. And from T.S. Apostolos for $1.99.
Honestly, I've never heard of that. Sorry. It's the first time I heard anyone say that. Okay. Don't know
say
how to
that. Say what I just said.
Okay. Thank you. Sorry, Kaz.
Oh, no problem. From T.S. Apostolos for $1.99. They say Sal is quite apocalyptic. JF, any apocalypse?
Absolutely. We are headed toward a form of apocalypse according to my book. It all starts with a woman and a man decide to go to a clinic, decide to modify their children genetically. Their children become excellent, beautiful. They don't have disease. They end up making more babies. Their babies want to in turn genetically modify their own babies. And eventually the social movements directs everyone to modify their genes. And eventually a computer ends up making decision for humanity and for its future evolution. Eventually the computer deprives us of our sexual organs because we don't need them anymore. We reproduce through computers and sexual selection disappears from humanity. The ensemble of everything that makes us free and that makes us sexual species in the search of success for ourselves disappears. And we become an ant colony style of evolutionary system where the queen, where our boss is the computer that makes our babies. So never commit genetic modification of your children. You will initiate a phenotypic revolution and the ultimate end of humanity with it.
May I comment? That seems like a big, and something that's on both our hearts.
Yes.
For different reasons. And I had a slide in my opening where I said that could be the Matrix, basically, apocalypse. And for different reasons, I'm concerned about genetic engineering, and I work for a genetic engineer who helped modify so many agricultural crops. But he's adamant we shouldn't do this for humans for different reasons. A lot of people don't know when you genetic engineer, you have a lot of failures. And are we going to try to genetically engineer children? And what happens when you're guaranteed to have so many birth defects? Are you going to keep the best and toss the rest? There are ethical concerns with that. Have to take that seriously, and it would bother a lot of people. So for different reasons, and then also we feel that the genome is just way too complex to really make any significant. I mean, we'll make improvements if we really try, but anyway, I'm with JF on this. It's like, let's not do this. Let's not go down that path. Thank you.
Okay. From High Roller 42 for $5, they say, how does religion explain reality? If God created space-time, what is God? It's for you, Sal.
Yeah, I had to actually think about that. I don't think religion explains. Religion is something you accept on faith that you cannot totally explain. That's why I like the talk about Gödel's incompleteness theorem. But it does, on some level, lead to testable predictions. And so, can you repeat the question, Kaz, just one more time? It was a good one.
How does religion explain reality? If God created space-time, what is God?
Yeah, I would just say he's the creator. He's all powerful, all knowing, and that's about all. And for me, as a human being, the explanations that I'm seeking in life are not the nature of God. That's very theological. The questions I face are, how should we live our lives? Why am I here? What should I do? And so I know that's a great question, but I can't answer it because it's not really anything I've really thought about, and it's not immediately relevant. Of concern is like, even something as basic as what do I do tomorrow? Thank you for the question.
Okay. From Bitter Truth, who's a member for 3 months, and they sent a super chat follow-up as well. So thank you, Bitter Truth, for that as well. Sal, are you willing to debate with me, that's Bitter Truth, on the Bible in light of science?
I'm trying to avoid debates these days. They take up a lot of time. But you've been so generous. I mean, I don't know how we would arrange it. I'm happy to have a discussion. I mean, I'd be the first to admit there are problems in the Bible for science, like Joshua's long day. I don't know how to solve that. So I'm just going to say you'd probably win a lot of the points at this juncture, if that makes you, that reassures you any. So, but thank you for the offer. I mean, I don't know how we can be in touch. And also thank you for being a member and for the question.
Okay, thank you so much. Last super chat. So if you have one for the debaters, ladies and gentlemen, please go ahead and send it in now. Samir Farsain for $2. They say, please explain skills being passed on through DNA. It's for you, Jeff.
Oh, well, if you take the DNA of a squirrel and you insert it into a cell that has been prepared to be an egg for a squirrel, and somehow you find an artificial uterus, or you implant it into the uterus of a squirrel mother, it's all you need for having a baby squirrel that will eventually gather nuts. And so that makes you a causal demonstration that DNA causes nut finding in squirrels. Now, how does it do it? And is there a nut finding gene? It doesn't have to be a nut finding gene, but you have a set of genes that encode the difference between a squirrel and a crocodile. And the crocodile doesn't want nuts, and the squirrel wants nuts. And it is to be found, the difference between the squirrel and the crocodile is to be found in the series of DNA letters by which they differ. And the causal demonstration of this is remove the DNA from the embryo of the squirrel, and you won't have a squirrel, and it won't look for nuts. It will be either a blob of fat and of nothingness, or it won't exist at all.
Okay, and we have 2 more super chat questions, and then that'll be it, ladies and gentlemen. Our timer is up, so don't send any more super chats. If you do, no chance that I won't guarantee that they'll be read. I will be taking all the other questions with me to the after show, so come with us if you'd like. From Dark Matter and Battle Rap for $5, they say, could mountains be the bases of giant petrified trees. Given the excess oxygen in that scenario, could dinosaur bones actually be giant bones?
Oh my, I don't know.
This is one of the craziest idea I've heard. I would love it, but I don't think it's I think that we see in the formation of mountain a folding of the Earth's structure, and so I don't think it's possible.
I wish I could answer your question, and I feel apologies, but thank you for the question. Sounds very compelling.
Nice. And the last one from Bitter Truth for $5. They say, I believe in evolution model, but I don't believe in creation. So just for your information.
Thank you.
Sal,
And thank you for your expressing your viewpoint. I used to believe in evolution. I saw it in the textbooks for, kind of the teleological picture of, a little microbe growing into like a fish, and then, a sea creature, and then it gets out of the water, becomes like the cavemen, and the cavemen become scientists become astronauts. I thought that was actually a beautiful picture. So, it's the complexity argument, and that has been with me. And I was an old Earth creationist most of my life. The young Earth creationism came later, actually, when I went to grad school and studied physics. But thank you for sharing your viewpoint. It's, maybe we'll run into each other again. Thank you for the question and super chat and comments.
Awesome. All right. So that's all the super chats we have. Thank you both so much for the riveting discussion. I really appreciate it. If there's any last words you wanted to say, go ahead.
I'm just waiting for the after show where we will be chilling, I guess.
Yes.
Definitely. I want to say thank you very much, Kaz, for doing this. JF, last words. I big fan of yours because of your conservative viewpoints, and I'm going to get in trouble for saying that. And that's all right. It could be one of the few debates where maybe we're both hated on. And Kaz, I really, really thank you for hosting this. Great moderation, and this has been probably one of the best debates I've been in. I kind of like this sort of interaction. So, and thank you to the audience and everyone who's watching.
Yes, definitely. Thank you to everybody in the audience. Thank you to everybody who sent in super chats. Thank you to the moderators in the chat. Thank you to James for creating this platform. And once again, thank you to the debaters who are the lifeblood of the show. So like it if you loved it, share it if you want to spread it, and subscribe. We have many more debates coming your way. Ken Ami versus Randolph, the 15th, 7 p.m. Eastern, Atheists versus Christians. And then once again, Debate Con coming on November 19th, Saturday, Plano, Texas. Tickets and fundraiser link are in the description. So please check that out as well. And the after show is linked in the description below. So if you want to come hear more, then please do. And with that, I just want to say thank you to everybody once again. Have a great night. And remember, keep sifting out the reasonable from the unreasonable. Have a great night.